Good afternoon. I'm very pleased to be here, and thanks for the opportunity to talk. I'm going to talk somewhat specifically about a particular guideline, and that's called the ICH M7. I'll describe that because what that does is it illustrates a really successful regulatory implementation of in silico models. And we've learned a lot as part of that process, and we can describe some of these learnings here, and I'd be happy when we're going through the demos, happy to do that. But some of the learnings are being applied to other guidances, other applications like assessment of extractables and leachables, residues of food, of leveraging the same principles. So the agenda today is, I'll just give you a quick overview of LeadScope. I'll go through the ICH M7 guidance, which is a guideline for pharmaceutical impurities, and talk about LeadScope solutions. So we were formed in 1997. For much of our history, we've been developing computational models. We've been forming consortia and publishing a lot in this area. And essentially, the products that we develop are toxicity databases, which can be used for read-across. In silico models, that includes both statistical or QSAR models, as well as expert alerts or rule-based, expert rule-based models. And we have tools for performing read-across too. Here's a quick summary of the types of models. So we have a lot more than just models that predict bacterial mutation, but they cover genetic tox, rodent carcinogenicity, reproductive and developmental toxicity, some organ toxicities, cardio, nephrotoxicity, and hepatotoxicity, as well as some neurotoxicity models. More recently, we've developed models to predict for classification purposes. So this one is the first one is an acute model that predicts GSH, or globally harmonized system categories, for acute toxicity, with the idea that it could be useful in transportation or other classification and labeling purposes. We do have skin sensitization models. Again, these are classification models that predict the ECOTOX categories, as well as ecotox models. And again, those predict GSH ecotoxicity classifications. So there's some of the more recent models that have been developed. We also have very large databases. So I have a database of over 400,000 chemicals with about 200,000 different studies. These are general toxicity database. And then we have some specialized databases for carcinogenicity and genetic tox. So the carcinogenicity database has about 3,500 chemicals, and the genetic tox has about 11,500 chemicals. So what is the guideline? This came out around 2015, 2016. It's an international guideline developed with partnerships with the FDA, the Japanese regulatory agencies, the European medicines agencies. And what's interesting about this guideline, it's not the first that mentions QSAR, but it's really the first ICH guideline where QSAR is a regulatory test. And it just describes some details about this test. It says that the first step in the process is to, if you have any data, if you have any bacterial mutation data, or if you've got any carcinogenicity data, then that's probably, you should use that information. And again, this guideline is focused just on impurities in pharmaceuticals. But in the absence of data, an in silico model, actually 2 in silico models can be used. And they go a little bit further. They say you can use one is a statistical-based methodology. The second one is an expert rule-based methodology. And as in the previous talk we've described, they do reference the OECD validation principles, those 5 validation principles that have been very nicely covered already. Um, The methodology is described a little bit. It says, you know, it's sufficient to use those, and the absence of an alert is a structural alert in 2 of these complementary systems is sufficient to conclude that has no mutagenic concern for the impurity. It does talk about an expert review, and we'll show some of that information as part of the working group exercises. So the solution that's really needed is you need to be able to search databases, both genetic toxicity database and carcinogenicity. We need the 2 different QSAR methodologies, and then we need to perform an expert review. So I'm in the demonstration, I'll go through how LeadScope can use the databases, both the GeneTox and carcinogenicity, how we can use the models, and how we can perform a complete regulatory submission based on just 4 example chemicals. And this is the tool we'll use. This is a LeadScope model applier. It's a fairly simple to use tool that's really focused on making predictions of toxicity. And we'll work through a number of chemicals. We'll see if we have any data. We'll apply the different methodologies. We'll then do an expert review of the information to then perform, you can see there's a column that says M7 class assignment. I'll describe what that class assignment is, and we'll go through how we can do an expert review of this information. Also, we'll review how to generate an actual regulatory submission document that we can provide. So I'll walk you through a tool to perform that. And that would be an executive summary of the information that's very important for regulators to see, as well as some optional appendices, such as if there's any full study reports that are needed to support any data that you used, as well as full in silico reports. Of course, the QMRF documents are all available for all these models, and that can be provided as well. So the 4 examples I'll walk through, very simple. There's one which is a clear negative, one that's a clear positive, one where we have data, and then one where we're going to perform an expert review. I won't go through these in detail, but we'll go through those in the exercise. I just want to point to a few resources. So on the stick, you'll have a number of publications. One is this was the result of a consortium of about 20 organizations. This included pharmaceutical companies, regulatory agencies, and this was to develop essentially a protocol for performing this analysis. As you saw, the guidance is quite short. There's not a lot of information in there, and there was a lot of questions that people using these technologies had. And so we put together a consortium and developed a protocol for performing that. And that's on the stick. And we'll walk through, you know, how to identify data, where to look for it, how to assess the quality of the study, how to document the results, how to perform an expert review. I mean, that's one of the more challenging parts. What does an expert review of the in silico results look like? And how to document the results and the expert review. We did a follow-on paper recently, and this was published earlier this year, because there was a lot more questions as it got implemented more and more, particularly around what does an out-of-domain mean, and how can we handle that information. So what we did was we looked at what's the risk of missing a mutagenic impurity based on an out-of-domain. So we applied that to about 15,000 chemicals, and you can see if you've got 2 negatives, the chances are it's about the same reproducibility as the Ames test. So it's quite low. It's about 8%. You have 2 positives, we're likely to conclude it. But then we've got these things in the between. We've got out of domain and a negative. What does that mean? Well, the paper will document what the relative risk is, and then it will suggest ways to perform an expert review that's consistent with that risk. So those 2 papers are on there, and very happy you showed the protocol paper, because this was really, these two papers was kind of the proof of concept that, you know, we could potentially write a protocol for an in silico assessment. And that's really what stemmed, or really was the starting point for developing the in silico protocol project, which I believe some of you heard about earlier in the conference. And there's two documents. One is the in silico protocol, and also the genetic toxicity in silico protocol, which was the first in silico protocol we developed. There are some other resources. For example, these papers show different case studies, how to perform an expert review. But then there's also documentation around difficult classes to support. So in doing an expert review like aromatic amines or aromatic N oxides, where there's a lot of conflicting information, there's a number of publications recently to support that. So I want to thank you for your attention, and happy to answer any questions. But just finally, I just want to acknowledge some of this work has been funded by the NIH. I'd like to thank the people at LeadScope, as well as all the co-authors on these papers. So I'll be happy to answer any questions. Thank you.